In this lesson, I'll show you two more examples on how to solve absolute inequalities. The question reads, solve for x where x is an element of all real numbers. Starting with the first inequality, in this particular question we can have up to two solutions for x. And the reason for that is because the left side here, this expression that's an absolute, can either be positive or negative. We don't know what it is, so we have to test for both. Let's start with the positive version. I'm going to rewrite this as 1 over 2x minus 7. Notice that I've dropped the absolute values, is less than or equal to 3. I'm going to solve for x. I'll take the 7 over. That makes it positive, so 3 plus 7 is 10. And we have 1 over 2x on the left side. Multiplying both sides by 2, that gets rid of this 2 and this 2. This leaves us with x must be less than or equal to 20. So that's one of the solutions for x. The other solution for x is if this expression were negative. So this time I'll put it in parentheses. 1 over 2x minus 7 is less than or equal to 3, and I'll put a factor of negative 1 being multiplied to the expression. As a result of that, I'll multiply this negative into these two terms where I have negative 1 over 2x, and negative times negative 7 is positive 7 is less than or equal to 3. Next, we bring this positive 7 term over to the right side where I have 3 minus 7 and negative 1 over 2x. On the left side, 3 minus 7 is equal to negative 4. And what I have to do now is multiply both sides by negative 2. Because if I multiply the left side by negative 2, this negative, that negative 2 and this 2 go away, leaving us with just x. And multiplying now the right side by negative 2 makes that positive 8. Now because we're multiplying both sides by a negative number, the inequality switches. So rather than being x is less than or equal to, x is now greater or equal to positive 8. Let's put these two numbers on a number line. Let's see where they are. So here's a number line, and I'll put x is greater than or equal to 8 over here. Let's say that is x is equal to 8. And let's say that this is x equal to 0, just for reference. And this is telling us that everything after, including 8, is a solution. This is telling us that x must be less than or equal to 20. Now, on a number line relative to x is equal to 8, that should be around here. And they're saying that everything to the left of this point is a solution. Therefore, x must be greater or equal to 8, but less than or equal to 20. Anything between x is equal to 8 to x is equal to 20 is a solution. Of course, you can take this a step further and choose numbers outside of this range and inside of this range to see if it satisfies the inequality. And you will find out that picking any number between 8 and 20 will satisfy this. Let's move on to question B. In question B, we have to replicate the same steps. So we'll first consider this as positive. We have 3x plus 4 is less than 6x plus 1. Bringing this 4 over, and the 6x over, we have 3x minus 6x, that's minus 3x, and 1 minus 4 is equal to negative 3. Dividing both sides by a negative number and a factor of 3 gives us x must be greater than negative 3 over negative 3, which is 1. Let's do the same thing, but this time 3x plus 4 is negative. Multiplying this negative into the parentheses, negative 3x minus 4 is less than 6x plus 1. Bringing that 6 over, bringing that 4 over, we have negative 3x minus 6x is less than 1 plus 4. 1 plus 4 is 5. Combining these two, we have negative 9x, and dividing both sides by negative 9 gives us, this switches, negative 5 over 9. So we have x is greater than negative 5 over 9, and x is 1. Let's place these on a number line once again. Let's say that that is x is equal to 0. X is greater than 1 is right here. So not including 1, I'll put a hollow circle to the right is a potential solution. Now this is telling us that x, which is negative 5 over 9, that's less than negative 1. So let's say that this is negative 1. Let's say our point is right here. this is telling us that everything to the right of this number is a solution. So if I were to draw this to the right, we have only this part of the number line that is consistent with both inequalities. Therefore, our only solution is x must be greater than 1. This won't work. Anything to the left won't work, but everything greater than 1 will work because that's where they both exist. And of course, you can test this out. You can place numbers that are in between -5/9 and 1 outside of this range, and you'll find out that this is the only possibility. And there you have it. That is how to solve absolute inequalities.